Hello everyone and welcome to today's webinar. Today we'll be covering our PV genset solutions with Fronius, and joining us today is from Elum Energy. We have Mr. Christian Cartens, who is the sales manager for the Southern African region for Elum Energy. Presenting is myself, Byron Kutza. I'm the technical advisor for the Southern African region, and David Mongi is also joining us, who is the technical advisor for the Eastern African region. So for today's agenda, we'll be doing a brief inverter overview, followed by Fronius's commercial inverters. We'll also be covering our load monitoring or / multi-metering for systems that you want to be using. Then we'll be covering our PV genset solutions from Fronius, so how to implement a generator into the system. And then lastly, we'll have a presentation done by Elum Energy. Before we start, please feel free to ask any questions during the webinar in the chat below, and your opinion is very important to us. So if you can gladly give us your opinion at the end of the webinar, just in a simple question, it will be greatly appreciated. So to start off, we'll be covering just a brief inverter overview. So from Fronius, we have what we call our commercial inverters. So this will be the Fronius Taro, which is available as an Echo and Taro standard. So the P and D variant refers to the DC inputs coming into the unit. So you can either be direct MC4 connections or P standing for pre-combined coming in. The Fronius Taro Echo only has one MPPT input, and it's available in power class 50 kilowatt and 100 kilowatt. The DC input voltage range on the unit is 580 to 1000. This is not the usable range, but the simple input range. And then for clients that are using the normal Fronius Taro, which is the standard one that has the 3 MPPT inputs, again, this unit is also available as a direct MC4 connections coming in on the DC side, or having your pre-combined cables coming in. So again, as mentioned, this unit has 3 MPPT inputs, but it's only rated at power class of 50 kilowatts. You'll notice that the DC input voltage range is slightly different. So from 580 to 1000 on the Echo. On the normal Taro, we have 200 to 1000 volts on the DC input voltage. Also, what's important to make note of with the new Fronius Taros is that we have got a higher input current variant on the D variant. So the direct variant is possible when using a 30 amp option inside the inboard fuses on the bottom of the board, is a possible variant that you can order. The Fronius Taro also introduced what we call AC daisy chaining. So this is where you can have an interconnection of up to 200 kilowatts can be interconnected between Taros itself. So this can be anything from 2 by 100 kilowatts or using the 4 by 50 kilowatt Taros. This allows us to have a cost saving, as we'll have no AC distribution board and only have one main AC disconnector being used. Again, this also allows us to get away with less AC cabling is then necessary, as we'll have only one main cable running back to our main distribution board that we are going to be using. Fronius has now introduced our new Fronius Voto unit. So this is the new commercial unit from Fronius, available in power class 25, 27, 30, and 33.3. The main benefits for the Fronius Voto is regarding the 4 MPPT trackers that are available on this unit. You also have 2 string inputs, so 8 string total inputs coming into the bottom of the unit. This unit is only available as a direct variant, so you'll have dedicated MC4s on the bottom of the unit to allow for your DC strings coming into the unit. You'll have 28 amp max rating per MPPT or per string, and the input voltage range has been drastically changed compared to the old Echo 27s and even on our Simo 20s, where your input voltage range is now 150 to 870 on the usable range, whereas compared to the older units such as the Echo, it was from 650 all the way to 870 on the usable range for that unit. So next we'll be covering is load monitoring / multi-metering. So Fronius always recommends that we have a Fronius smart meter in the system. It is a bidirectional meter, so you can also measuring our feed-in and consumption paths. The measured data is then sent to the inverter itself, and then obviously to the monitoring platform that we're going to be using. If we have, for example, onboard APIs that we are using through a data manager card, we can rely on this data also being distributed out through our dedicated APIs. It's a basis for Fronius SolarWeb. So with SolarWeb and using your Fronius smart meter, we can then see the load consumption, as well as if we want to monitor a separate dedicated load, we can then have additional meters inside the system. So again, it is the key to full monitoring and energy efficiency flow control within the household. So again, it always also relies on us having a relay that opens and closes with if there is PV surplus, we would then need to have a Fronius smart meter in the system. So you've got energy meter at the feeding point for the Fronius smart meter. We'll have the TS65A-3, the TS100, and the TS5KA-3, and Fronius's new Fronius smart meter IP. The Fronius smart meter IP is different to the old 5KA in being that it's the type of communications that this meter is then using, as the old meters are only relying on Modbus RTU communications. This smart meter IP can use both Modbus TCP or using Modbus RTU communications for your communication from the smart meter straight back to our dedicated master inverter. So just showing a brief diagram of how we would have the meter communicating from our grid point itself to then obviously be communicating directly back to our dedicated inverter. So what's important to note is if we are using what we call energy profiling. So this is if you have a client that has a normal grid side inverter, but they want to now introduce a secondary source coming into the system, such as a generator or a third-party inverter, but we want to monitor exactly how much power that inverter or source is producing, we would then need to do a dedicated secondary smart meter in the system. So we would still have our main Fronius smart meter, and then we would then communicate via our secondary meters to that dedicated load or source to then tell SolarWeb how much energy is then being produced. I'll now be handing over to David, who is going to continue the presentation.
Thank you, Byron. I'll be doing the next session where we now tackle the PV-genset solution, how it looks like, and the integration and control that is required then together with Elum. Of course, that will be tackled by the colleague from Elum later. So the question we would ask ourselves is, why would we discuss this PV-genset kind of solution? And one of the things to note is that we want to improve the stability of the entire system. So if you have at least two sources of energy, you are definitely better than just having one source of energy. And then the ease of integration into an existing genset system makes the idea of having PV power retrofitted to a genset system quite interesting and in that sense. And then of course, we are thinking about how we can save on costs. So we are talking here about lowering the energy prices. So if you are not relying on diesel fuel on its own for the generator, you have the possibility to lower the price of energy if you bring in a cheaper cost of energy, such as a PV array. Then, of course, with a PV array, you can achieve rapid amortization of the entire system. So therefore, this becomes a real business case. In addition to that, you are able to decouple from full dependence on fossil fuels. So of course, you are still going to run quite a bit on the diesel power that is used to power the generator. But because you are sort of now building a fuel safe kind of system, you can save quite a bit of the dependence on the diesel itself. And in addition to that, reduce your CO2 footprint. When it comes to how the PV system, the PV genset system is defined by Fronius, we're thinking about a system that has primarily a diesel generator with now the addition of Fronius string inverter into that kind of system. In addition to that, we have to think about a control mechanism. So here we have a plant controller such as an Elum controller. And of course, this entire setup is used to power up the existing load network. So a simple schematic, how this solution looks like. So we have your Tauro coupled to an existing PV diesel generator grid. Then you have the CTs that are measuring the flow of current to the loads, and therefore this information as far as the load requirements is then used by the system controller to be able to adjust production by the Fronius inverters in this case. So looking at the entire spectrum, we have the diesel generator, and then we have, of course, the PV inverter as the two key elements. But of course, the controller becomes also very, very important in this sense to be able to mitigate or control how power is produced, especially by the Fronius inverters. There could be the public grid available in the network or in the setup, but it could be that it's not reliable, and therefore you need to think about when the diesel generator is operating and you have the inverters producing power, the system controller or the plant controller in this case must still be able to limit production of inverter power to be able to allow the generator to cover a certain minimum amount of power in the system. If you look at a PV genset system, we can discuss two penetration scenarios. So one is the low penetration PV genset kind of setup, in which case, as we can see in this load profile, we have probably over 1.6 megawatts of consumption. If you look at the overall production, this pink curve, we have less than 700 kilowatts in terms of the PV production. And therefore, in this case, because the PV production is quite low compared to the maximum load consumption, then this kind of scenario, we refer to it as a low penetration scenario. In this kind of low penetration scenario, we actually do not require a plant controller in this case, because there is no possibility of backfeeding some of the PV power to the generator side. But on the flip side, we also discuss about a high penetration scenario, whereby now the PV power, as we can see with the red curve, is significantly higher compared to the overall load. So in this case, we can see that we are now approaching something like 1.4 megawatts of PV production, and compare this to the load consumption, which is just about 1.6 megawatts. We can see that this is a scenario whereby the PV generation is significantly higher. And in this case, for sure, we do require a plant controller to be able to manage how power is produced depending on load requirements. So if you look at the operation deep inside the PV genset system, we have several things to be considered. So number one, if you look, for example, at the consumption in the blue curve, we can tell second by second how much power is being consumed by the loads. And also in consideration to that, we have to look at what is the minimum genset loading. So this is where the plant controller becomes very, very important to be able to manage the genset minimum loading that is required permanently during production. And then, of course, we have to look at the available PV power, which you can see in the red dotted line, and then the actual used PV power. So if you look at some instances, we can see that there could be a sudden drop in the load consumption, And we need the plant controller to be able to tell the inverters now that there is a requirement for the output to be reduced. As you can see here, there is also a dip in the amount of PV power that is produced. And then after that, as the production and consumption continues, the plant controller is adjusting accordingly depending on the load requirements. In terms of the design rules for a PV genset system, we have quite a number of things that needs to be considered. One of them I've already mentioned, which is the 30% minimum genset load. So unless stated by the generator manufacturer, it's always required that a diesel generator should not be loaded lower than the 30% of the nameplate rating. When it comes to the inverter side, the maximum AC inverter power that you inject into a generator grid should be within around 60 to 70% of the genset power, and therefore that also takes into consideration the 30% minimum genset loading. And then of course it's very, very important before you bring the integration of PV power into a generator grid, you know your load profile so that you can see what is your maximum, the average, as well as the daytime loads, as well as if there are any seasonal changes, to be able to know how these sources of energy or sources of power are going to be managed. Additional design recommendations from us is in terms of the DC to AC ratio when it comes to the inverter side. So you have to take care of what are the recommendations there, but we always recommend that you oversize your inverter accordingly to be able to mitigate things like aging of the panels, dust on the modules and things like that, so that the inverters can always generate near maximum power that is designed. Then, of course, the PV genset system requires one common point of measurement. I think we already mentioned the current measurement during the introduction part. And then, of course, for a professional or advanced system, this would be like the high penetration scenario. Then a PV or a plant controller is always required to make sure that the system is safely designed. Looking at a specific sizing example, how this would look like. So we look at the same load profile that we have seen before. So we have to determine quite a number of things here. The first thing to look at or to determine would be what is the minimum genset load that is required. The second thing to think about is the inverter power, the kilowatt or the kVA that you are going to inject into this generator grid. And then, of course, look at what is the maximum PV power. We have already talked about or mentioned the DC to AC ratio. So the kilowatt peak maximum that you're going to design your PV system with. And then, of course, look at what is the peak demand on the load side. So if you look at all these factors, then you can come up with a relatively good and stable PV genset system. And going further to analyze those key points, we can see from that particular load profile is that the minimum genset load would be about 540 kilowatts. So, and the generator load must be therefore 1.8 megawatts. So if you divide this by the power factor, the total generator size that is required for this particular installation would be about 2.25 MVA, because here we are looking at the maximum consumption on the load side, divide by the genset power factor, then you get into the apparent power of the generator that is going to be required for this particular installation. On the load side, if you look at the peak demand of the load, then minus the minimum genset load, this would leave us a space of about 1.16 MVA for inverter power. And then what is most important is to look at the average daytime load, because this is what we are designing our PV system for, because this PV system has no battery storage in this case, and therefore most of the available PV energy is produced and consumed during the day. And therefore, if we look at the average daytime load of 1.2 megawatts minus the minimum genset load, then we can see that our average daytime load would require something like 0.66 MVA of inverter power. And therefore, the question becomes, between the 1.16 MVA inverter power and the 0.6 MVA inverter power, which one to use? So this would depend on the load profile. So you have to do an analysis based on the hour-to-hour resolution, so that to know whether this 1.16 MVA is too oversized and therefore you end up generating too much PV power that is not used, or to go with a lower number or a lower figure whereby you can have consistent consumption of the PV power throughout the day. When it comes to the PV array, as mentioned, you have the flexibility to over design. So for the Vatos and the Tauros that have already been mentioned by my colleague, you can do about 150% oversizing. What is important also is to look at the localized cost of energy, so of PV versus fossil fuels, so that you know whether your particular design is going to have a quick payback period or not. For design, we are able to support you and we can assist you in system planning to be able to optimize the PV system in terms of maximum savings that are desired. And for that, we of course do require a detailed load profile. So this has to be provided, a synthetic load profile as well, and then of course which gensets you desire to use. Based on this information, we have two options for design. So we can do just a technical design or do both a technical and an economic design. So after which then, of course, we are able to give a detailed report. But of course, this applies only if you're not able to design your own PV genset system. So as mentioned before, there are two possibilities for PV genset. One is the PV genset advanced, and the other one is the PV genset professional. So the differentiation here depends on the number of generators that are being used. So, but in terms of the configuration, the idea is the same, that you are going to require one primary system controller. You could have other secondary controllers that are connected to each of the generators, depending on whether the generators are synchronous or asynchronous, and therefore, but the entire control system is based on the primary plant controller. So depending on the power ranges that you are designing for, if you're coming from just about 50 kilowatt going on to 100 kilowatts to a maximum of 2 megawatts, then this is what we refer to as the PV genset advanced. And if you have multiple gensets that are in the range of 200 kilowatts going on to 5 megawatts, this is what we refer to as a professional PV genset kind of system. So that guides you into those different classifications. As far as communication of data is concerned, as already mentioned, I think Byron already covered it in terms of communication for the smart meter especially. So we can achieve the same kind of communication between the Fronius inverters and the plant controllers. So if you have the Elum controller on one side, then you're able to do Modbus RTU into the inverters, and you're able to then share the production commands from the plant controller into the inverters. So this applies both for the newer Fronius inverters, such as the Vato and the Tauro, and the same kind of protocol is used for the communication with the older Fronius inverters, because you could have an existing site with the older inverters, such as the Fronius Snap Inverter Echo and Simos. If you want to retrofit a PV genset kind of control, then you can use Modbus TCP or Modbus RTU to be able to communicate with the Fronius inverter in this case. When it comes to the customer segments, we think about where the PV genset system can be used. There are quite a number of possibilities. If you have factory operations, if you are in tourism, if you are in mining, and especially mining, because most of these sites are off-grid and in remote areas, meaning that they are primarily powered by diesel generators, that becomes a very attractive sector or customer segment for use of PV genset. If also you are in food processing, you could be in a grid connected area or not. If you're in a grid connected area, in most cases, you have a diesel generator as a backup source of power in case the public grid suffers blackout. Lastly, just quickly want to share a reference with you because we cannot just be talking about things that have not been done. So we have a specific site in Zimbabwe that was recently done. This was commissioned in December of 2023. The system size on the PV side is about 500 kilowatt peak. It's a rooftop installation. So the first phase of this site had about 5,100P inverters. And then, of course, there was an extension later. So the control there is by Elum Energy controller. And the yield per year, this I think was for 2024, was about 668.73 megawatt hours, CO2 savings of 576 tons, and total savings about 227,000 US dollars. So on this point, I would like to hand over to Christian from Elum to be able to do the next part for the Elum presentation. So Christian, if you can take over from her.
Yes, thanks so much. Let me share my screen. Just give me 2 seconds. All right. Can you see my screen, Byron?
Yes.
All right. So welcome to everyone, and thanks for having me today. I would like to start off with a very simple question. What do we do if you don't know? There's actually a lot of words that mean the same thing. So in the industry, you'll hear things like EMS, controllers, SCADA, and each one of you have their own understanding of what it means. But essentially, we have a controller where we can set up the logic of control, or you can set that up yourself or with the help of our teams, as well as monitor your project or remotely. For us, there are actually a lot of benefits to using our system, especially for genset integration. But if I have to choose one, it's our high compatibility rate with any device, any equipment. So as a third-party controller, Elum is actually aiming to be compatible with any brand. That said, there's two parts of it for our discussion today. It's the PV side, where we communicate with the inverters, and then there's the genset side, where we communicate with the genset controller or an external meter if the genset controller is not capable of external comms. Today, we'll discuss the following points. Product overview, where I'll discuss the description and features of the controller, what it looks like, technical specs, implementation architecture, even our configuration software, and our monitoring. The second one is the commissioning steps, where and what to do when commissioning a Elum system, things like wiring diagrams, easy configuration of the controller, and functional tests. Thirdly, 10 mistakes to avoid. So a very good way to remember all the important bits. If nothing else in the manual, if you read nothing else in this manual, please read this. And then fourth, the Elum Academy. So what is the Elum Academy and how can you become certified. So for our first one, the product overview, there are actually a lot of different layouts, equipment, and even grid codes related to monitoring and control. But the vision of our founders is a device that can match all the requirements in terms of equipment, project layouts, as well as grid codes. So at the end of the day, we would like to provide you as the EPC the power of our controllers. And we know this works, and it could not only benefit your client, but also your business, because it can be used to scale and grow your business. To do this, we need to consider the two parts we provide. The first part is the e-power control. On number 4, you'll see that. And the first part is the e-power control, split into 3. So you've got your PV on number 1, your gensets on 2, and your grid on 3. Of course, our solution can also be used off-grid, which you will just drop the third one. Then the second one is our e-power monitor, which basically is our monitoring platform where all the data is sent from the controller because it is connected to the internet. So we are introducing 2 models today, the SD and SD Plus. We have larger models as well that do a little bit more, but today we'll focus on these 2. There's 3 things we need to consider when we install this and why are we installing it. The first one is maximizing solar energy production and not being so dependent on diesel fuel. The second one is ensuring continuous and reliable power even when the grid fails. And the third is to minimize the operational costs and basically the fuel consumption, as well as extend the genset's lifespan because it's not running at 100% almost all of the time. The purpose of the SD and SD Plus, there's a little bit of a difference between the 2. The one is designed for managing one single genset, and the SD Plus, the second one, is for multiple genset integrations for up to 4 generators. And this would still be under 300 kilowatts of PV capacity. And once again, the primary goal is to reduce your reliance on diesel and ensure that you have continuous power supply on your project. There are 6 main features and capabilities that come embedded with the controllers, the SD and SD Plus. The first one is the integration with distributed energy systems. So we are compatible with PV inverters, a lot of genset controllers, meters, and even EV chargers, which makes it a very lucrative system. We utilize Modbus protocols, so Modbus TCP or RTU, to do this communication because almost all equipment on the market is Modbus compatible already. All we need is the Modbus register map in order to integrate a new device for you. In terms of solar diesel integration, that's one of the key features. So there's a seamless control between PV systems and diesel gensets, ensuring that we prioritize PV production as much as possible. Then third, a few operating modes that are available. So you've got your grid time mode, which is grid connected and ensuring we comply with your grid requirements in terms of sending power back to the grid or importing power. Islanded mode, where we ensure a reliable power supply by balancing the solar and diesel generation, and we want to avoid genset underloading at all costs, as well as the backup mode to ensure this is more done by the generator, but this is to ensure the reliability of the system. 4 is feed-in management, and with this, the first feature is zero export mode. It's basically grid limitation, almost relates to the third point here where it says minimum import mode. So it prevents the excess solar power from being fed back into the grid. This can be set up to a specific value. The maximum export mode, this can also be set up to a specific value, as well as the minimum import mode. Number 5, the genset minimum loading, which is, I think, one of the key features. Based on a percentage, you are able to set this up yourself, depending on what type of generator you have or what the manufacturer actually allows. And then 6, fail-safe strategies. So when communication fails, we need to have a system in place to actually ensure your PV production doesn't go all the way back to your generator and damages it. And when that happens, we automatically reduce the solar production to 0 to make sure we prevent any damage from happening. Here's a quick representation of our controller. DIN rail mounted with 2 LAN ports on the front and 2 RS485 ports on the bottom. Here's our technical specifications of SD and SD+. The maximum number of devices, maximum number of PV inverters, gensets, meters, IO modules, and even grid connections. The full technical specs can be found on our website, free to download. So for the architecture diagram, just a quick overview once again. You've got your connection, your internet connection between the controller itself and the cloud monitoring. Then you've got your data connections between the controller and the different equipment. So that could either be Modbus TCP Ethernet or Modbus RTU RS485. This is between the sensors and the controller, the PV inverters, genset controllers, and any kind of meter as well. So for the Elum configuration tool, it's rather something adequately designed to reduce commissioning time, first of all. This is by making use of the user-friendly interface. There's really no coding needed. This is not a black box. It can be used to quickly configure the EMS. And also for easy diagnosis when you need simplified error reporting or analysis that you need to do. This brings us to the monitoring part, which is the last part of the overview. With the monitoring, it is used to do complete site monitoring. It can be used to do site analysis with the different KPIs that are available, and even portfolio overview for all your projects, as well as the reporting and data export. I think this is one feature that is really needed in most cases to ensure your client is up to date of what's happening with their system. A few additional features that makes it even better is alarms. So for alarms, we have the anomaly detection and also the notification of those anomalies. Notifications are sent via email. And the second one is remote access to our site controller itself. So here's a representation of one of the screens you would likely see on our Monitoring Pro version. You've got estimated PV in red, top right, over the actual PV production. You've got at the bottom the PV inverter heat map. And on the left there, you've got some other KPIs, including communication status. So including the communication status, if it's on or off, Elum has really made it easy to drill down into things like the individual strings or string level of the monitoring of these PV inverters. Right, so we are at our second point. So commissioning steps. This is quite the crucial part. So keep with me if you can, but please let me know in the comments or the chat section if there's any questions. So let's start off. How do we start? We start off by reading the documentation. Our system is really complex in a way, but also simple or made simple by all the documentation we provide. So read the data sheets, the prerequisite documents, the quick start guide, even the user manual, as well as the connect and config guide. Especially the connect and config guide, you'll see exactly how to connect specific PV inverters, batteries, meters, genset controllers, and even sensors. Then on the second part, there's also a manual for our monitoring platform on how to use and operate within the limits. Step 2, plan the communication architecture. How are you going to connect the specific devices on site? There's two options. One is through serial RS485 and other through Ethernet RJ45. So Elum has two serial ports. On these ports, things to note is every device should have a unique slave ID and also the same baud rate, parity, byte size, and stop bits. And the wiring you should use is shielded twisted pair. This is to avoid any interference or possible interference on these lines, which can happen quite easily with serial connections. The limits on this is the length of the cable that should not exceed 1,200 meters or 1.2 kilometers, and termination resistors to ensure stability of the system. For Ethernet, there's two ports. Port 2 is dedicated to the eConf configuration tool that we'll go through, and port 1 is used to connect any other device that you need. You can also use this to connect to the internet and even use it to connect a switch to extend the amount of ports you need. For this communication, you need to have a unique IP address for each device. The limits on it is a maximum of 300 meters and it should not exceed that. Here's a quick representation of what it might look like, what the communication diagram might look like on your end when designing a system. We've got a switch here to extend the one port we have. Connected to that, we've got 3 Taros, internet access, and on the serial port 1 and 2, we've got a load meter and grid meter, as well as a genset meter. For the second part, it's a table outlining how you would set up these devices. So first off, you've got your 3 inverters, all have different slave ID addresses. slave IP addresses because it's connected on the LAN port. And then you've got your 3 meters, 2 of them, grid and load, connected on the one serial port. So they have different slave IDs. And the last one, the genset meter, connected on its own RS485 port. So to notice here on the front view, you'll see the 2 Ethernet ports. And on the bottom view, especially, you'll see the 2 serial ports and how to connect them pin-wise. Pin 3 to positive, pin 4 negative, and 5 ground. So I've already mentioned what goes where, which pin goes where, and termination of these data wires is also crucial, especially at the end of each line. And once again, shielded wires should be used when connecting these devices in serial connection. Just a quick overview on connecting meters. So power meters, obviously you have to connect or power up the meter. That's the diagram on the left. And on the right, you'll see your voltage references as well as your CTs connected to the 3 lines and neutral. Step 4, configure the slave devices. We've got solar inverters and gensets in this case that we need to configure. And we actually need to monitor quite a few things on these devices. They are more or less the same. We need to monitor the active power output measurements, communicate the maximum power output set points, as well as collect the accessible measurements useful for monitoring of the operation. In terms of, I would almost say extras, like the PV string level monitoring and so on. This is true for both the solar inverters and the generators. For generators, essentially we'll have things like fuel level, temperature, those type of things. One important note is to be sure that you install a reverse power protection if it's not included in the genset controller on board of the genset itself, because our controller is not a protection relay. So just note that. So configuring the slave devices for power meters, once again, we need a few registers like the active power output and any other measurements like frequency or voltage. What needs to be configured is the correct protocols on these meters. The current transformer ratio, so make sure that this is set up correctly in order to have a viable system. And for bigger systems, usually you have a voltage transformer ratio that needs to be set up exactly the same way as you would set up the current transformer ratio. And then the measurement type. This is very, very important, as we need to have positive and negative measurements for these meters in order to adequately control it from our end. Step 5, wiring and installing the controller. Wiring, we have 12 to 24 volt DC input voltage. We usually supply a 24 volt UPS with a battery. Then step 6, configuring the controller. Once your controller is connected to the internet and you connect your laptop, you'll see the screen popping up. It's to set a password. That's the first step. The second step would be your setting up your internet connection. As you'll see on the top, it basically takes you all the way through from step 1 to step 7, which is the finishing touches. Then we scan or we search for updates and update the controller. Thirdly, you will input the site name as well as the coordinates for this project. Third, we've got the network configuration, where basically you need to add a network connection, either LAN or serial, depending on where your devices are connected. It's as easy as clicking add device and going through setting up the baud rate, if it's baud rate, byte size, and parity, if it's serial, and the IP if it is LAN. Then we have data forwarding configuration that you can set up. This is where you'll be able to send the data collected to any other third-party monitoring platform that you need to send it to. People like VCOM or QoS Energy, and even your own FTP servers. After that, you need to set up the control for the generator. So size of the generator, the minimum loading, reactive power control, enabled, not enabled. For PV, you'd set up the power values, dispatch strategies, ramp rate control, and even if you want, you can prioritize the reactive power production over active power production. That brings us to the last part, save and start. Once you start the system, you'll see this screen, which will show you the EMS is active and have a view of everything that you've gone through on the left. And you can also individually view your devices connected or not connected at all times. So the functional test basically takes you through a whole lot of things, but essentially the environment gives you the opportunity to test if the EMS has started, the PV injection stopped, all devices are connected, the power meters data is very consistent, and on-grid or grid-connected configuration is done. The test scope is done on all the equipment, so inverters, genset, meters, etc. This is the test procedure. I'm not going to go through everything, but our team will help you through this as well, if need be, on any of your installations. So, test completion and validation. The whole installation can be considered successfully commissioned once all the expected outcomes listed in the user manual were met at each step of this test procedure on the previous page. So once again, like I said, there's 10 mistakes to avoid. It's in the manual. And once again, it's a very good way to remember the important bits. And if nothing else, please read this. Then for our last bit of this presentation, it brings me to Elum Academy. We've recently launched this initiative, and it's basically to get people at a place where we can provide them with training and a certification platform. Our mission for this is for you to gain the knowledge, tools, and best practices in order to deploy our systems independently. Thirdly, we have a few programs. The one we've launched now is the installer program, but coming soon, there'll be a distribution program as well as a partner program. The key learning materials available for this is product and documentation, as well as data sheets, the installation guides, and step-by-step tutorials. So with this, you'll have videos taking you through the whole process. Configuration and troubleshooting, once again, same thing, as well as case studies and real-world applications. This is for all of our products, so not just this diesel genset integration, but as you can see on the top right, our SD, HFS, ES, ES Plus, MC range, ZE zero export, as well as our DL range, which is our data logger. Now, who is this ideal for? We think it is ideal for the engineers, the technicians, and the energy professionals. Why would you get certified? It's basically to validate your skills as an engineer or technician and actually be able to install our product with ease and confidence. It boosts your credibility, of course. This can be something used where you can stand out a little bit, since you can load the certification that you get onto LinkedIn and show off to the rest of the community. So how it works is you choose your specialization, you choose your option, which product do you want to do, you study the online resources, you pass the exam, and you get the official certificate. And in this case, we have it free before the 22nd of May this year. That is it. Thank you very much for listening, and the Fronius team for organizing this. If there are any questions, we can relate to them afterwards, I think, and get back to you. So please don't hesitate to send us an email or send in the chat box.
All right. Thank you, Christian, for that exciting presentation. I think we just do the concluding parts and then we finalize the webinar. So for any further information regarding Fronius, as usual, please feel free to get in touch with any of our respective technical advisors. For West Africa, Cyprian; for South Africa, Byron; or myself for the Eastern African region. For other queries, technical training, sales, and all these kind of things, we have the contact information at the top. And yes, this brings us to the very end of our session today. I think the only question I've seen Christian being asked